Hi everyone. Today we're going to talk about rate of change and slope. And remember, just like in 4.1, we're talking about graphs of linear functions right now. So let's start with the first part, rate of change. And when I talk about a rate, what I mean is how fast something's happening. And a rate of change is how fast a variable is changing with respect to another variable. Now, for most of our equations, the variables are x and y. Those are our two most common variables. So if I ask you for the rate of change in one of our equations, what I'm usually asking is, we're going to make a fraction. We're going to compare by making a fraction or a ratio. And on the top, you put the change in y. And on the bottom, you put the change in x. And basically, like for a linear function, you might say for every one x that changes, y changes by 5. And we noticed that last module when I said you can tell that a function is linear because as the x changes, the y, you're always adding the same thing each time. That's actually our rate of change there. Now, in a word problem, a lot of times it's not x and y, and that's when it becomes even more meaningful. So in a word problem, I said you might have something like change in distance over change in time. And what that means is, like, let's say you're driving your car at 55 miles per hour. That's a rate of change. Because what you're saying is the change in distance is 55 miles. The change in time is 1 hour. That's what per hour means. So you're saying for every 1 hour that passes, my distance changes by 55 miles. And that's another example of a rate of change. All right, so let's go back to our linear functions. In a linear function, another name for the rate of change is slope. We're going to talk a lot about the slope of a line. Now, if you know any 2 points on the line, then you can find the slope using what we call the slope formula. And I put the slope formula on here. It's y2 minus y1 over x2 minus x1. Now you might look at that and think that's so confusing. There's all these 2's and 1's, and what does that mean? It's pretty simple. I'll explain it on the next slide, but what I want you to realize is we're taking 2 points. On top, we're subtracting the y's. Now, if you take any 2 y's and you subtract them, that tells the difference, or the distance between them, the change. And then we do the same thing with the x's. You take your 2 x's, you subtract them to see how much they've changed. So on top, you're comparing the change in y, and on bottom, you're comparing the change in x. So let's talk about this formula to make sure you understand it. I said don't be confused by that notation. y2, y1, x2, x1. It's just 2 points. Every point is x comma y. I'll write it up here. Every point on a line is x comma y. If I have more than one of them, I number them. So if I have another point here, x comma y, what I do is I say, okay, well, we have 2 points. They're both x, y. I can't call them both x and y because they're different numbers. So we say, well, since this was our first one, this will be x1 and y1. And since this is our second one, this will be x2 and y2. So now all of a sudden you have just the x, y values from 2 different points. So I said this one right here, that's 1 point. That's the first point, x, y, and we're calling it x1, y1. So the x part of that value goes on the bottom there, and the y part goes on top. And then I said over here, this is the second one. This is y2 over x2. Or basically it's the second point, x2 comma y2, and you put those numbers in there. So let me do an example and show you how this is used. I said find the slope of the line that goes through the points 5, -1 and -3, 1. So if I start the question the way I did on the last slide, I look at it and I go, okay, well, I gave you 2 points. Each one of these has an x and a y. But see, they're different. I look at it and I say the first point says x is 5, the second point says x is -3. The first point says y is -1, the second one says it's +1. So we need to differentiate. So let's make this the first point, x1, y1, and let's make this one the second, x2, y2. And then the equation I gave you to find the slope, y2 minus y1 over x2 minus x1. And let's put the points in, put the numbers in. So the first thing on top is y2. I look up at y2 right here, and I say, what number is that? That's a 1. And then it's minus y1, which is right here. And I say, what number was y1? It was negative 1. So I have 1 minus, I'm going to put it in parentheses, 1 minus negative 1. And on the bottom, I have x2, which is right here, negative 3. Negative 3. And then it's minus x1, which is 5. So I put all my numbers in. Let's see what we end up with. On top, remember when you have a minus a negative, it turns into plus a positive. So 1 minus negative 1 is the same as having 1 plus positive 1, which is 2. And on the bottom, I have negative 3 minus 5 more would be negative 8. So I get positive 2 over negative 8. For my final answer, I'm going to say I have a positive number divided by a negative number. That's going to be negative. I'm going to leave it as a fraction, but I'm going to reduce it. Instead of leaving it as 2 over 8, I'm going to realize I can divide both of those by 2 and make it 1/4. So the answer is, the slope is negative 1/4. Now, before I move on, a lot of times students ask me, like, how did you know which one was x1, y1, and which one was x2, y2? The answer is I didn't, and it doesn't matter. I just picked one. So what I'm going to do, I'm going to work out this same question. I'm going to show you you'll get the same answer either way. But I'm going to switch it, and I'm going to make this one x1, y1, and this one x2, y2. And I'll show you that we'll get the exact same answer. I'm going to do y2 minus y1 over x2 minus x1, and I'm going to plug in the new numbers. So this time, when I'm looking back, y2 is negative 1 minus y1, which is positive 1 this time, and it's all over x2, which is 5, minus x1, which is negative 3. So this time on top, I get negative 1 minus 1, which is negative 2. And on bottom, this time I get the minus a negative. 5 minus a negative 3 is the same as 5 plus negative 3, which is positive 8. Now what you notice, we got the exact same numbers, 2 over 8. And the answer is the same because last time the negative was on bottom, and this time the negative is on top. But it doesn't matter, because negative divided by negative, or negative divided by negative is negative, sorry. Negative divided by positive is negative, and 2 over 8 reduces to 1/4. So it doesn't matter which one is x1, y1, and which one is x2, y2. It's going to work out no matter what. Just make sure you don't switch in the middle. Like if you called this one x1 and this one x2, so you're mixing them up, that would matter. That would get you the wrong answer if you have one of each. One point has to be x1, y1, and the other one has to be x2, y2. Now the last part of this lesson is to talk about something called rise over run. So let's say instead of an equation, you have, or instead of 2 points on the line, you have the actual graph of the line. A lot of times we use a trick, we call it rise over run to find the slope. We said slope is change in y over change in x, and change in y, remember when you're talking about the y value of a point, you're talking about how far you go up or down. So change in y means if I'm going from one point to another point on a graph, how far did I go straight up or down? And then change in x, that's what we call rise. Change in x is how far I go left or right. That's what we call run. So basically, the rise is how far it goes either up you put a positive number, or down, you put a negative number. For run, that's how x is changing. So you're asking yourself, how far did I go to the right, which would be a positive number, or to the left for a negative. So for our last example today, let's find the slope of this line, and I'm not going to use y2 minus y1 over x2 minus x1. I'm going to try to do it an easier way. So what I'm going to do, when I talk about rise over run, I'm going to start at this point right here, the point -1, 4. And I'm going to get to the other point by going over here and then down this way. So you ask yourself, okay, it's actually going to be what we call the run first. How far did I go over to the right? Well, it looks like I went over 1, 2, 3 spots to the right, and that's to the right, so it's positive. Then you say the rise. Now the rise is down, so it's definitely going to be negative. Remember, up would be positive, down is negative. So it's definitely a negative number, and you say, how far did I go down? 1, 2, 3, 4, 5, 6. So by figuring that out, rise over run, the rise, I'll write it out, rise over run, the rise would be -6 because it didn't rise, it dropped, so we went down 6, and the run would be +3 for 3 to the right. And then you would simplify it. You'd say negative divided by positive is negative, and 6 divided by 3 is 2. So the answer is -2. Now, it doesn't matter which way you go. The same thing I told you last time. Let's say, for example, I did this question backwards where I started at the other point. Let's say I started at the 2, -2, and I said I'm going to go up this many and then backwards this many. Well, see, then the rise is +6, but see, now the run is to the left, so it would be -3. So when you did rise over run, you would have +6 over -3, which gives you the same answer. It's still -2. So it doesn't matter if you go from one point to the other, or the second point back to the first. You're just measuring how far you go right or left for run, and how far up or down for rise. There is one last quick thing about slope. We say that a perfectly horizontal or flat line has a slope of 0. Now the reason for that is because if I drew a perfectly horizontal line like this, and I do rise over run, the rise is always 0. Because remember, if I go from one point to another, let's say I'm going from this point here to this point here, it didn't go up or down at all, so the rise is 0. Now run doesn't matter, because 0 divided by any number is still 0. So let's say they were 5 spaces apart. When I do rise over run, I get 0 over 5, which is 0. Now a perfectly vertical line, we say that has undefined slope. So let's say I had a perfectly vertical line, and I was doing rise over run from here to here. Well, then what happens is the run is 0. Because see, as I go from one point to the other, if they're lined up right above each other, it's not going to the right or to the left. It's not moving sideways, so run is 0. Now, you can't divide by 0. That's a math rule. Like, again, let's say those points up and down were 5 spots apart, so the rise over run was 5 over 0. 5 divided by 0 is not 0. It's undefined. You can't divide by 0. It's basically saying if I took the number 5 and split it up into 0 parts, how many would each one be? That's not a question. You can't split a number into 0 parts. So this would be undefined. So that's a rule you always want to remember, those 2 bullet points right there. Any perfectly flat horizontal line, you say has a slope of 0. But any straight up and down vertical line, we say the slope is undefined. And that's our last piece for today.